Okay, children. Now we are going to discuss another Q&A, right. So in this Q&A, right, I will give the question like this. My question based on this reaction: 2A 2AX2 gas gives 2AX gas and X2 gas, right. So that is my reaction is. So now first of all we want to check whether it is balanced. Here 2A there, and there are 2A and 4x there, and then 2x and this 2x 4x. Now what I want to do, I want to find the rate of this reaction. So we know that how fast that AX2 concentration decreases, how fast the AX2 concentration decreases, same fast the reaction proceeds, right. So when we concern this one, you see that when the time pass like this, when the time is passed, what happened to the concentration of AX2 gas? Concentration of AX2 gas decreases, right. With the time, concentration of AX2 gas decreases, right. So like that. So then they will ask you to determine, average reaction rate for this one, right. They ask to find the average reaction rate, right. So how to find the average reaction rate? We will find the average reaction rate like this, right. Average reaction, I want to find the average reaction rate. Average reaction rate, you remember that earlier diagram in earlier video I showed you that average reaction means actually final minus initial divided by the total time taken, right. So average reaction rate is we can find it like this. Then average reaction rate, it will be in this way, right. So think that average reaction rate will be, that is average reaction rate. How to find that average reaction rate is equal minus, that is because this concentration is decreasing, minus delta, this is delta change of concentration of AX2 divided by delta T. So how to find that change of concentration of AX2? Actually that change of concentration means final value minus initial value. So what is the final value here? The final value is 0.0088, that is minus, right, 0.0088 minus what initial value is, but 0.0500, right. Then the time taken for all this process, what the total time taken? Total time taken is 20, right. Total time taken is 20. So this should be divided by 20. So the answer will be, right, 0.00206 moles per cubic decimeter per second, because here the moles per cubic decimeter unit and here the second is the unit. So the overall unit is moles per cubic decimeter per second. So now if they give the question like this, they have given the equation and they have given a set of data. Using this set of data, how can I find the average reaction rate? One method is like this, or else we have to draw a graph like this. Using the graph, we will draw the tangent from initial position to final position and draw a line like this. Find the gradient of that. That also will be similar to this value, right. Then in the same question they ask another one, how to find the initial reaction rate. They will ask you how to find the initial reaction rate, right. So how can I find the initial reaction rate of this one? How can I find the initial reaction rate for this one? This is the reaction, you remember, with the time the rate of reaction decrease like this, right? And then initial rate of reaction is found by drawing a tangent from the 0th time. This time is actually, this is the 0th time, so we draw the tangent for this place, the brown color one. If you find the gradient of this thing, you get initial rate of reaction. That's how we get initial rate of reaction. This tangent, to find the gradient of that tangent is equal initial rate of reaction. That is the way to find the initial rate of reaction. So that's simple, right? So the next thing, sometimes they will ask a question like this, right? Initial rate is greater or lower than the average rate. Now what do you think about the initial rate is greater or lower than the average rate? Now you remember that this is the initial, in any of this reaction, this is the initial rate reaction and this is the average rate of reaction. Always initial rate of reaction is greater than the average rate of reaction. For an example, if I concern this particular place, you see this gradient is more than this gradient, right? So why the initial rate of reaction is greater than the average rate of reaction? At the initial point there are more reactant particles, so more collisions occur, so more fast reaction occurs. Average means concerning whole process. Therefore when the time is passed, number of particles decreases, collisions decreases, therefore the rate of reaction decreases, right? And the next one, if they ask us to find the instantaneous reaction. Now for an example, if they ask what is the rate at the 50th second, so if this is the 50th second, so we draw a line like this and then draw a tangent in this way, we find the gradient of this tangent, right? So that is how we find the rate of reaction. So in this chemical kinetics lesson, now we start from the chemical kinetics origin, that is what is rate of reaction, how to measure the rate of reaction, and many other things. What are the factors affecting for the rate of reaction, and then the next one, rate of reaction respect to reactants, rate of reaction respect to products, like that many things we discuss. So this is how the main 4 types of reaction rates are measured. So this is I guess this is 5th or 6th video reaction about this chemical kinetics. I hope you all refer these videos, and then I will send the notes to the WhatsApp group. So please notice that if we have the time after the COVID period, we will discuss those things in our normal class. Okay, then thank you.